Thank you very much for clicking on this video. I am so much happy to welcome you to this video, and this is an exposition for teachers and also a light to students who are about to write their Waec examination. I just a guideline. I have not much thing to do with the titration. Just have to get the idea in your memory. This is called permanganometric titration, or some people can call it permanganate titration. Any of them you use, that is correct. So that is what we are expecting to be seeing in our Waec Practical 2024. So for teachers, that is the first set I am dealing with. This type of titration is actually looking at making use of potassium tetraoxomanganate 7 with iron 2 tetraoxosulfates, or sometimes we can even use ethane dioic acid for it, because ethane dioic acid is also a good reducing agent. Okay, so the major purpose in this titration is for us to be able to determine the concentration of oxidizing agent, which is the potassium tetraoxomanganate 7, and also the reducing agent here, which is the iron 2 tetraoxosulfate 6. Okay, this process is actually a standardization process. You need to know that, and mostly it involves this type of titration involves potassium tetraoxomanganate 7 titrated against iron 2 tetraoxosulfate 6 or ethane dioic acid. So you need to know that. Remember, FeSO4 here is a reducing agent, just like C2H2O4 is a reducing agent. Okay, so what are actually the things that I actually need to know as a student in this work? So in the bullet, I'm going to have KMnO4 solution, and the color is purple. And in the conical flask, I'm going to have 25 centimeter cube of iron 2 tetraoxosulfate 6, and I'm going to add 2 drops to 3 drops of the concentrated tetraoxosulfate 6 acid, about 2 molar concentration. So you need to be a little bit up to that for us to do this work perfectly. The indicator is going to be the color change of KMnO4. The color change is going to move from purple to something. So it's going to be a self indicator. That is what we're going to use. Yes, so the KMnO4 here is a self indicator. What I mean by KMnO4 is the potassium tetraoxomanganate 7. That is what I mean by the KMnO4. It's going to have a color change. As you can see on the screen, I already have set up how the color will look like in the beginning and at the end. So the KMnO4 is purple, but at the end of the titration is going to turn to be pink in color. Okay, the end point, that is just what I just said, is going to be a pale pink color. Okay, for the manual given to us from Waec, these are what we are asked to do. Get the mass concentration of the solution A, which they ask us to use 1.58 gram to dissolve it in 1 dm cube. So the mass concentration is 1.58 gram over 1 dm cube. So that is what we have as 1.58 gram per dm cube. So this is for majorly for this one will serve for 5 students. So if you have it dissolving 1.58 gram in 1 dm cube, you can serve for 5 students. Okay, the same thing goes with the solution B. They say 5.5 gram is going to be dissolved in 1 dm cube. So if you have 5 students, you can serve. So the major volume of the pipette is 25 centimeter cube, although some school will use 20 centimeter cube. So from this idea, we need to find the molecular mass of the purple KMnO4. I'm sorry to be using the KMnO4 for it. What I mean by KMnO4 is potassium tetraoxomanganate 7, but in a shorter form I'll be calling it KMnO4. Okay, so the total value of that is the molar mass of it, or let's say relative molecular mass of it, will give us 158. But if we convert relative molecular mass to molar mass, it gives us 158 gram per mole. So if we do the same thing with the iron 2 tetraoxosulfate 6, is going to give us 152. So we need to now compare molar concentration of KMnO4, we know that the formula for molar concentration is mass concentration all over molar mass. So we insert the values, it will give us 0.01 mole per dm cube. If we do the same thing with that of iron 2 tetra orthosulfate 6, it will give us approximately 0.0362 mole per dm cube. Remember, I'm using 3 significant figures because most times Waec and most examination body use 3 significant figures. So here, there are so many things we have with us here, as you can see on the screen. So the next thing we need to look into is the equation, so that we can be able to find the number of volume of acid that we're going to use, the average titer we can be looking at. Mind you, that is what we can be looking at. So from the equation we have, we need 5 moles of iron to react with 1 mole of the KMnO4 and 8 mole of hydrogen ion, which if you're using tetrasulfate 6 acid is actually 4 moles of tetrasulfate 6 acid. But we're not more interested in the tetrasulfate 6 acid here for now, because we have already covered it by saying that we're going to use 2 to 3 moles. So we are going to be looking at, this is 5. That means that our Na from here is going to give us 1, because we are assuming that MnO4 is going to be in the burette. So it is serving as a solution A. So we have it at Na equals to 1. So we have our Nb equals to 5. I hope you get where I get this 5. That is why I colored it differently. Okay. So if we have understood that we have our Ca already, that's the concentration of solution A, concentration of solution B, volume of B. Now we need to look for volume of A. This is how we go for it. So the volume of A is going to give us 18.10 centimeter cube, approximately to 3 significant figure. So our expectation or our expected volume of acid to be used, if for instance they ask us to use KMnO4 in the burette, is going to be about 18.10 centimeter cube. So your value should be lying between 18 centimeter cube and 18.5 centimeter cube, if for instance you have a good chemical from the start. But wait, what if these Waec examiners change the pattern? For instance, if they say that the KMnO4 is going to serve as solution B, in the sense that they are going to add it in the, or you're going to pipette it and add it to the conical flask first. So be careful. If they are saying this, that means that the expected answer should be lying on 34.53 centimeter cube. So your expected answer might be between 34 to 35 centimeter cube. That is if there is invert of the reaction. The normal reaction should be KMnO4 in the burette and FeSO4 to be in the conical flask. But if for instance there is invert of it, this is what you're going to have. Thank you very much for watching this video, and I urge you not to forget to like, subscribe